Okay, today we're looking at going from rectangular to polar or polar to rectangular. And a couple things we need is how does everything relate to each other on the radius delta side. Remember, polar, you have your radius or your distance and theta, sorry. And then on rectangular, you have x and y. So how do these relate to each other? So from the other videos, if you had your angle theta here and your radius or distance, and then it creates a triangle. So if you're thinking about r theta and x and y would still be here. So how does it relate? You're looking at a right triangle and you're using SOHCAHTOA. So sine of theta is going to be y over r. Cosine of theta is going to be x over r. And tangent of theta is going to be y over x. Okay, things that we already know just from trig. And that's why really polar has a lot to do with trig functions. Now, if we were solving for y, right, you would just multiply both sides by r, and you would get r sine theta. If you're multiplying or solving for x, same thing, r cosine theta, right? And then you have something for x and y. Also, we know that, let's say we do Pythagorean theorem, you're also going to have x squared plus y squared equals r squared. Okay, so we could use all of these to convert back and forth. So for example, let's say we have a point negative 3 comma pi over 3, and we want to convert to rectangular. Okay, so what you want to use here is, since we are given r and theta, right, and we want to find x and y, this one's kind of nice. You just need to use x equals r cosine theta and y equals r sine theta. So in this situation, we'll have y equal to negative 3 sine pi over 3 and x negative 3 cosine pi over 3. This winds up giving us negative 3 times root 3 over 2 and negative 3 times 1/2. So we wind up with negative 3 root 3 over 2 and negative 3 over 2. Just a couple things if you think about the idea of when we were sketching these before. If this was the point negative 3 where your radius is negative and you're going pi over 3, remember how this works, right? You're at your initial side or your positive x-axis, and our angle would be pi over 3, and normally you would be going in this direction, but because it's a negative 3, you're actually going back that direction, right? 3 units. And that would be your point negative 3 pi over 3. So it should make sense where if we're getting a negative 3/2, negative 3 root 3 over 2, what quadrant would that be in? And that would be in the third, right, quadrant. And we could see here that that is also in the third quadrant, so it matches up. The next one I would like to show you is maybe going from rectangular to polar. So let's say you had negative 4, 4. Let's just do that. Okay, and then we want to convert to polar. All right, so in this situation, the one that you want to use, the formula that you would like to use is tangent, because it's a way that you could find, because you have x and y, and you could find the angle that way. So here we'll have tangent of theta is going to equal, remember it's y over x. So here we have tan theta is equal to 4 over negative 4 or negative 1. So when is tangent negative 1? We have it at two values. It could either be in the second quadrant, which would be 3 pi over 4, or it could be in the fourth quadrant, which is 7 pi over 4. The way you would have to think about which one do you use, right? Go back to the point and think about where negative 4, 4 will be. So like negative 4, 4 is going to be in the second quadrant. So we're going to use 3 pi over 4 as our angle. Okay, and then how do we find the radius? Well, if you think about this point going out, I don't like how that triangle looks, but if you think about, right, 4, 4, negative 4, 4, if that's our point, right, this would be negative 4, this would be 4, and we are looking for the radius. So you could use r squared equals x squared plus y squared. And in this case, we wind up getting so 16 plus 16 is 32. So we would get 4 root 2 as our radius. So then our point is 4 root 2, comma 3 pi over 4. And that's how you would convert